I'd like to start off by thanking Daniel for inviting me to speak tonight, and also to congratulate Daniel on what he's managed to do with this ICO in such a short time. I met Daniel in December of last year when this was pretty much an idea, and now what he's been able to achieve, and believe me, I get involved in a lot of these in one capacity or another, as an advisor mainly, and this is quite extraordinary, so well done, Daniel. Now, tonight I'm going to be talking about blockchain generally, and not specific about ICOs. I have some slides on ICOs that I'll cover as we get to it. I have a lot of slides, so I'm not going to be able to cover absolutely everything I've got on this, but that's okay. If there's anything that you want me to expand on later or explain, come and find me tonight or look me up, and I'll be happy to do that. So very quickly, introduction. I'm going to talk about blockchain essentials, what you need to know if you're thinking about getting in this game. And I just saw from your responses a lot of people are thinking about getting into this game. Not ICOs, I'm talking about blockchain. I'm going to talk about use cases for a blockchain beyond the payment system. Bitcoin blockchain is a payment system, but it can be much more than that. I'm going to talk about public versus private blockchains. Again, this is stuff you need to know if you're thinking about jumping into a blockchain which is being run as a consortium or some sort of private permissioned type of application. I'll have a brief look at ICOs and how you can kind of evaluate the value of the coins. And if we have time, I'll go through some blockchain economics, but I don't think we will, so you might have to come and see me about that if you're interested. Okay, so firstly, just about me. Got a lot of blockchain expertise. I've been doing deep dive into it for quite a few years now. A bunch of qualifications. I've been doing a lot of study. So much study, it's like a slow death, all the study. You could say it's killing me by degrees. A lot of experience, 35 years plus in academia and in corporate world, 17 plus years. So about half of that has been in the finance sector. This is what I do nowadays, consultancy, so there's a bunch of services there, and never mind that. Now, the ultimate goal of the blockchain. So this is stuff that you need to know. There's a point to doing this, right? So if you don't catch anything I say, latch on to the key points. We like cash. Why do we like cash? Because there are no intermediaries. It's immediate, it's guaranteed, it's irreversible. It doesn't cost you anything to hand over a wad of cash to someone. So the Bitcoin challenge, so the genius who came up with Bitcoin was trying to solve this question: how do you do this on the internet? Right? So what do we need? An electronic currency, a way to prove ownership, right? Ownership of cash, it's in your pocket. Electronically, it's different. And we need a way to transfer ownership peer-to-peer, electronically. Okay, so we have a currency, it's Bitcoin, which is founded on a network of self-interested, independent and permissionless nodes. This is all very important, so remember this. It's not backed by any authority or any tangible asset. Bitcoin has value because everyone in the network agrees that it has value. And one of the main reasons why they all agree it has value is because it requires an investment to dig it up out of the ground, so to speak, to mine it. Another very important point, which we'll come to again later. So we need a way to prove ownership. And this is how it's done. The blockchain that you've all heard about is itself the ledger, record of everybody's ownership of Bitcoins. Now the nodes, these are all the servers around the world which are involved in the network of blockchain, keep a copy of the node, of the blockchain, of the ledger. So there's no chart of accounts. Transactions actually spend other transactions. What does that mean? Well, I'll try and explain that later because it's not always that easy to understand. ownership is defined as access to spend, and it's implemented through cryptographic keys. Okay, so we need a way to transfer ownership. It's done through these cryptographic keys. So they come in pairs. They are mathematically linked in such a way that if you have the private key, you can find out what the public key is. And a public key, like for Bitcoin, is essentially your Bitcoin address. Right? Same thing, public key, Bitcoin address. The private key is something that the owner knows and keeps secret forever. Now, a transfer of ownership of Bitcoin means locking the Bitcoin funds to a new key. So this is what a transaction looks like. Simplified, you have a bunch of inputs, a bunch of outputs, and in each output you have an amount of Bitcoin that you're transferring, and you have the Bitcoin address of the person that you want to spend it to. So you're locking funds to that Bitcoin address, or if you want to say it, to that public key. Now once you've done that, you can't take it back, right? The only person who gets those funds now, after you've done this, is the person that has the private key, which is linked to that public address. So a transaction spends another transaction. I've got down here BTC address and signature. The signature is created with the private key. Now here's the trick. You can create a signature with a private key, but you don't need to reveal what the private key is. But once you've got a signature of a transaction, everyone can check that it's yours, right? Because they've got your public key. Everyone knows your public key, or everyone you give it out to knows it. So they can check that it's your signature, but they can do it without ever revealing what the private key is. This is a very, very powerful technique. It's what really makes Bitcoin one of the main things that makes Bitcoin work so well. Now here's an important thing you need to understand if you have Bitcoins or any other cryptocurrency. Whoever knows your private key owns that Bitcoin or that cryptocurrency. So if you are if you have an exchange wallet where all you get is a login and a password, and that's how you trade your Bitcoins or buy your Bitcoins, and you don't actually know what your private key is, you just know how to get into the website and see your account, who's got your private key? Whoever your service provider is, right? So if you trust them, that's fine, and why not, right? We trust our banks all the time, right? And they hold our money, yeah? So if you trust whoever's holding your Bitcoins, that's fine. But just remember this, they own your Bitcoins and they let you trade and buy and sell it at their own discretion. You can manage private keys yourself, but I don't go into that here. Right, here's a rough sketch of the blockchain. A block is just a collection of transactions. There's a special transaction which pays the block reward to the winning miner. The miners are all competing with each other to be the next person to put a block. And the winner gets, at the moment, 12.5 Bitcoins. So every 10 minutes, one of the miners scores a win and they get 12.5 Bitcoins for doing that. And each block contains a kind of a summary of the previous block. Too technical to go into if you don't already know it, but this is one of the techniques that makes sure that you can't forge a block. And it's done this way, right, on purpose, because this is what you need to do if you want to have electronic cash, right? So there's a lot of overheads here. So I showed you before a network where everyone's keeping a copy of the blockchain. Then we have this complicated system where we're chaining all these blocks together. And as I said before, transactions spend over transactions. Now, here's some implications of that. This is what a transaction literally looks like, right? Just hexadecimal numbers. This is what it looks like in readable form, human readable form. Okay, here's the takeaway. Blockchain technology is very good at delivering the goal of electronic cash because it's peer-to-peer, it's trustless, no centralized authority, it's impossible to forge, and it's resistance against cyber attacks. Blockchain technology in itself is not appropriate for conventional systems. Why? Because as a database, the ledger is quite poor compared to a relational database. And you just saw an example of what the ledger looks like, right? It's just a string of numbers, and you stick all those in a great long chain. That's your ledger. There's a lot of redundant processing. All the nodes are replicating the processing. Mining requires a lot of investment, and transactions are relatively slow. Slow in the sense that if you have your own system where you've got a database and you're storing transactions, that's like a few microseconds. For transactions across networks, it's a few seconds. That does not mean that the public blockchain is not good for anything else. On the contrary, it is very good for many different things. It means that the technology is not fit for other purposes. So, if your IT manager or CTO comes to you and says, boss, let's get rid of our old back-end system, it's old technology, we've got to replace it with a new shiny technology blockchain, don't do it. But why build on the blockchain then? Because Bitcoin is not just a payment system. Transactions can be programmed. So what you have is a huge computing system. And then you inherit all the benefits of the public blockchain. Public blockchain. This is what they are. I don't have time to go through this in any detail, but it's a bunch of cool stuff, all right? Now, here's something you should know. Transactions can carry data. So you're not just having a payment system, you can actually store data in a transaction. Metadata such as contract terms and conditions. If you don't have enough space for all the contracts and conditions, then you can actually link it to an external file. So this is a way that you can carry tokens like a bond or some other derivative over the top of the public blockchain. Transactions can also be programmed. So you can put executable logic within the transactions, and that means you do some fantastic stuff. You can have terms and conditions which are self-enforcing, or you can have business rules which execute themselves. And there's lots of different ways to do this. You could do it in one single transaction if it's complex enough. You could chain them together. You could have a bunch of oracles that interact with the world and create your transactions. You can have a mixture of these and some other really cool stuff that I just can't tell you tonight. Otherwise I'd have to kid you. That'd be sad. Okay, so those different modes I just talked about have different applications in the world. This is just a smattering I'm going to show you very, very quickly. For non-specific sectors, like just generally companies are going to have lots of use cases for the blockchain. But for specific verticals, there's a whole bunch of different use cases, which I can't go into, but I will quickly go through financial products. This is something else that you really need to understand. If you're familiar with capital markets, you know that the way that capital markets right now is quite complicated. It's inherited from the paper-based system last century, and we still have all of these intermediaries, right? A lot of these intermediaries are just not necessary anymore. There's too much already, right? If you told me to replace capital markets processing right now, I could do it for you without the blockchain, and you'd save millions. Anyone could. Any systems architect could do it. But with the blockchain, you can save even more. Why? Because you don't need the banks either. Okay, so with the blockchain, you have a network of nodes that do a whole bunch of stuff for you. The blockchain itself is the registrar. The blockchain itself is the clearing agency. The blockchain obviates the need for banks. I'm not going to go through the detail of this slide, too complicated. All right, very quickly, just to finish off now, because I'm getting this wind up from Tim. just quickly, private blockchains prima facie don't make sense. I'm not telling you not to do private blockchains. I'm going to give you some information. You make up your own mind. Come and see me if you want more. The main reason that the blockchain's design exists is because it supports a permissionless, trustless network. If you have a permissioned, trustful network, a private blockchain, then you're already undermining the reason for that. So right now, if you've got a company that brokers a deal between Alice Limited and Bob Limited, then money transfers through the bank. The product you're selling, the bond, the share, derivative, whatever, goes through the clearing agency. So what do? We get rid of the clearing agency, we get rid of the banks. Fantastic. Yes, of course it is. But here's the thing. You have a network of permission nodes which are actually doing the validation of those transactions. Now, in a traditional model, it's just party A and party B do the transaction, they reconcile with the company that's setting the rules, or with each other, or both. But if you've tried to build this using a private blockchain model, everyone in the network is validating those transactions between A and B. Isn't that the same as blockchain? Yes, it is. But with the public blockchain, that's necessary, right? Because you're doing electronic cash. You're not doing a product like a bond. So this is what you should be doing, if you agree with me, which you may not. You transact over the top of the blockchain, but you're doing it over the public blockchain, not the private blockchain. Alice and Bob don't even need to be part of the network. They just need to know how to transact, that's to say, send their transactions over the network. I've got a lot more, but I'm going to stop because otherwise, Tim's giving me this dagger look right now. So I'm going to close it off there.
Please
Thank you very
put your
much.
hands together for Stef.